Hi. Today's lesson is going to be on collections. More specific. Today's lesson. More specifically, what are collections and how they can be used. In this lesson, we'll cover. Hi. In this lesson. Today's lesson is going to be on collections. More specific. More specifically, what are collections and how they can be used. In this lesson, we will cover the 4 collection data types in the Python programming language of list, tuple, set, and dictionary. A list is basically a collection that's ordered and changeable, allows duplicate members. A tuple is a collection that is ordered but unchangeable, allows duplicate members as well. A set is a collection which is unordered and unindexed and has no duplicate numbers. Dictionary is a collection which is unordered and changeable, but it doesn't have duplicate keys or members. All right, let's get started. Okay, so what we have here is hello live lessons inside of a main function, and we have the main function being called at the bottom of the Python file. And let's run this to make sure everything is working properly. Okay, great. So we have hello live lessons. The first collection that we're going to show is the list. And basically the list is going to have integers inside of it. So we're going to call it int list. So let's go ahead and create the int list. All right. And the list data type, or the list collection, has functionality to it. It has verbs added to it, basically making the list an object type or a class. And one of the functions or methods, one of the methods of the int list class is append. And what we're going to append are 4 different numbers: 11, 22, 33, and 44. And we're going to print those. So let's go ahead and create a print for the int list. And we're going to use interpolation. In our previous lessons, we used the %s to create a new string by combining the original string and whatever comes after the % here. So basically, it's what gets interpolated into a new string. So we're going to pass the int list to be created as a new string here. And we're going to print that. Okay, great. So what we have here is the int list with 11, 22, 33, and 44. The first position of the list is position 0. The second is position 22, and the third is position 33, and the fourth is position 44. When I say the first, it's always indexed as 0. We'll see an example of that in just one moment. So what I want to do is print the int list at index 0, and it should give us back 11. It should give us 11. And you know what? Let's go ahead with index 1. No, 0 is fine. All right, so when we print this, it's going to be 11. So it's going to be int at list position 0, and it's going to show the number 11. Okay, great. All right. Another thing that lists can do, or operations that can be taken on a list, is delete. So if we wanted to remove one of the numbers from this list, we basically just say int list, and then let's give it position 1 to delete. And then we're going to print the entire list again. All right. So let's see what that looks like. Okay, great. So position 1 was the 22 before, and that 22 is no longer there. It was deleted from the list. The next thing that we want to do is to work on tuples. So the tuples are similar to arrays, but they use a different syntax. So first thing is that they're immutable. So they can't be changed. Once you create a string, it can't be changed, but you can create a copy of it, and the new version of it can be created in a different way. The same thing happens with tuples. You can create a tuple, but you can't change it, but you can access it and basically create a new version of it if you decide to make some adjustments to the tuple. Okay, so the first tuple that we're going to have is a tuple of strings. And we're going to assign it the word 11. And we're also going to assign the word 22. 22. I'm going to leave the spaces out, but we could have spaces in there if we wanted to because it's just a string. And we're also going to do 33, and we're going to do 44. Okay. All right. So that's our tuple of strings. Let's go ahead and print that out. It's basically going to show exactly as it is displayed, as you can see it here, with the parentheses and comma separated. But let's print it out anyway. We have the string tuple, or tuple of strings. And we are going to interpolate a new string, or a new tuple, a new string from the combination of the previous string and the %s and the new tuple. All right, so let's go ahead and print that guy out. All right, so let's see, we have a tuple of strings. Oh, I left one thing off. Okay. The problem with this is that it didn't actually print the tuple because we need to reference each one of the tuple variables inside of the tuple. So the first one is 11. Second one is 22, the third one is 33, and the fourth one is 44. Okay, so with this, we get to see the tuple of strings. Let's see. It's printing a tuple. Oh, let's see. Let's have parentheses. All right. Let's go ahead and declare them. The first, second, third, and fourth items in the tuple. So yeah, when you have a tuple, if you want to access those items, you could do it individually by indexing them with similar to what we do here. But we can also access them with a comma with a comma separated list of variables. So with the comma separated list, we're able to access them individually. So the first variable will print as first string, because it's a string tuple. First string. Right. Percent S. Percent first. Okay. All right. Oh, okay. That's not a good thing. Needed the percent. Okay, yeah, here we go. The tuple of strings. All right. So basically, we can access all of the individual variables within the tuple by declaring them in a comma separated list and putting the actual tuple on the right hand side of the equal sign, and then we have access to all of the tuple variables. This is the second tuple string, and this is the third, and this is the fourth. All right. Oh. Second, third, and all right. Okay, great. So we have the first tuple string 11, the second tuple string 22, and the third tuple string 33, and the fourth tuple string 44. Okay, great. All right, so moving along. There is also a way to add to a tuple. So let's go ahead and add to this tuple in the sense of creating a new tuple by adding to the tuple. So we're going to call the new variable adjusted tuple. And this one is going to take the original tuple of strings and we're going to use the basically concatenation operator, and we're going to add 55 to this adjusted tuple, and we're going to print the adjusted tuple. All right, and it's going to have one more item to display, and let's go ahead and use that one, the adjusted tuple. Okay, great. So we have adjusted tuple of strings 11, 22, 33, 44, and 55. All right, and that's pretty much the gist of tuples. Yeah. Moving along, there's also the data type of float that we can put in a set. So what a float set could look like is this, where we have floating point numbers of 11.0, 22.0, 33.0, and 44.0. All right. And with the set, there aren't going to be any duplicate values. So if I try to do this, it should give an error. I guess it doesn't, or it just gets rid of the duplicates. So let's go ahead and print the float set. Be float set. And yeah, so we tried to put 44 in here twice, and basically it removed one of them because sets can't have duplicates. So let's just go ahead and take that one out. So that is how you can create a set. But if we wanted to validate that some number is inside of the set, we could do something like this. Print 11 in float set and %s, and we are going to check 11 in float set, or yeah. All right. And also we want to check if another number that we know is not inside of the float set, 55. Okay, great. So 11 is in the float set because it's here, and 55 is not in the float set. And also, if you haven't seen this before, the in operator is basically saying, does the thing on the right-hand side contain the thing on the left-hand side? So is 11 inside of the float set, or is 55 inside of the float set? All right. Moving along. There's also a data type of dictionary. So we're going to create an Int Dictionary. And this Int Dictionary is going to contain strings as the keys. So the first key is going to reference the number 11. And the second key is going to reference the number 22. And the third key is going to reference the number 33. And the fourth key is going to reference the number 44. And we're going to print this guy out. So print, and this would be Int Dictionary. S and percent and Int Dictionary. Right. Okay, so let's see what that looks like. Okay, yeah, so the dictionary keys are not ordered. They basically come in random order because they're not indexed. You know, you're not accessing the first one at position 0. You're accessing the list of keys in whatever order they came. So the key fourth came first, and then second, and then third, and then first was the last key that was actually displayed. And the values for each one of the keys is directly beside each one. So fourth has a value of 44. Second key has a value of 22. Third key has a value of 33. First key has a value of 11. All right. So one other thing that you can do with the dictionary is you can actually access it with the brackets, and we can create a new key if we want it, and we can set a new value for the new key, and then we can reprint to show the new value shows has been added. Okay, great. So what we have here is fourth has 44, fifth has 55, and so on. So we see that the new key that was created by subscripting the Int Dictionary, and then we added the value to that key by setting it equal to 55. All right. Okay, lastly, what we want to cover is the dictionary of lists, but the lists are going to be of strings. So we're going to have two different collections merged into one. So the first layer of the collections is going to be the dictionary, which is going to be string keys. The keys are going to be strings. And the second layer of these two collections together is going to be a list of strings. So every single key within this new dictionary is going to be a list. And let's see what that looks like. So we're going to have a dictionary called String List Dictionary. And that will have a key of first, or the first item will have a key of first. And within the value portion, we're going to create a list of strings. So the first string is going to be 11. The second be 12. And then we're going to have two more. 13 and 14. All right. And basically, we're going to duplicate this. This is going to be the second key. This is going to be the third key. This is going to be the fourth key. And the values for the second key will be 21, 22, 23, 24. The values for the third key will be 31, 32, 33, 34. And the values in the string list of the fourth key will be 41, 42, 43, and 44. All right, so let's go ahead and print this guy out. So this is a string list dictionary. Right? And let's see what that looks like. Okay, so what we have here is the fourth key has the values, has a list as its value, but the list has values of 41, 42, 43, and 44, and so on. We have the second, and then we have the third, and then we have the first as the last key. Okay, to adjust the stringless dictionary, we're going to use one of the functions that we learned earlier from the list. We're going to use the append function or method. We're going to use the append method to add on new values to the list, to individual list items within the dictionary. All right, so first thing we want to do is reference the string list dictionary, and then we're going to reference the key for first. And this key accesses a list of strings directly. So what we're going to do is call to the append method of that list, and then we're going to append the value of 15. And we're going to repeat this with the other keys. So the second is going to receive the value of 25. The third is going to receive the value of 35. And the fourth is going to receive the value of 45. And we're going to print the adjusted stringless dictionary. Right. So yeah, notice that there's more data. We have the fourth key has 41, 42, 43, 44, and 45 now. And the second has 21, 22, 23, 24, and 25, and so on. Each one of those appended values got added to the individual list. All right. And that looks like that is pretty much the lesson on the basic collections. Just to kind of give a glimpse of what it looks like behind the scenes, basically all of the basic built-in structures or collections are the list, the dictionary, the tuple, and the set, which we gave examples for. But there are also newer non-built-in structures that are called stack, queue, tree, linked list, graph, and hash map. If you guys want to do a lesson on those, please make a suggestion in the list of suggestions for the next lessons. You'll find that in the link at the bottom of this guide here. It's git.io/JQF3D. All right. Oh, and capital J, lowercase q, capital F, the number 3, and capital D to get to the lesson suggestions for Python lessons. All right. So let's see if we have some questions. Yes, it looks like we have some questions. Okay, so the first question is, can you convert a string into a tuple? If the string is a properly formatted tuple, yes. Let's go back to the tuples. Let's see. All right, so let's go here and create a string tuple. And within the string tuple, we're going to need the parentheses for a tuple, and we're going to need the value. So let's say our values are 111, 222, 333, and 444. All right. There's a function in Python called Eval, and it basically takes the string value and evaluates it into a Python native data type, or basically a built-in data structure. So let's go ahead and create a new tuple variable called converted tuple. And we're going to call to this eval function. And we're going to pass in the string tuple. And now we have a converted tuple here. And we want to print this. So oops. All right. Let's see. This is the converted tuple of integers, but let's just call it converted tuple. Okay. And it has 4 values. All right. Let's see what this looks like. So yeah, let's go ahead and put some lines here. Just to separate out what's what. As a matter of fact, let's go ahead and go above the tuples and split the int list away from it, and the sets, we can split the sets away from everything else. And we can split the dictionaries as well. Okay. All right. Okay, so let's run this guy. Okay, yes. So what we have here is the literal converted tuple. So it actually converted the tuple, and the way we can kind of test whether the variables came from that tuple or can come from that tuple. Let's go ahead and reference all of the values of the converted tuple. So let's go ahead and say converted tuple, and then we have the first, second, third, and fourth. These aren't strings, so let's just bring them back. Okay, so let's see what that looks like to make sure that we did get an actual tuple back. Yeah, so we have 111, 222, 333, and 444. Okay, hopefully that answers your question. We have another question of, can you add a tuple? Yes. So basically concatenation or adding happens when you take a tuple and then you use the plus operator, and then you take another tuple and then you have an adjusted tuple. So we basically already covered this one. So yes, you can add tuples. All right. One more question. Are the set the same as in mathematics or discrete math with unions? The set. Oh. Yeah. So with the set. So basically, yes, we can union and intersect and create a difference between all of the sets. So let's go ahead and create a second set, and we're going to call it float set 2. Right? So this is float set 1. 1. And now float set 2. Float set 2. 2. 2. Okay, let's make different numbers for float set 2. So instead of these numbers, we are going to have some different numbers. Let's go with 55.0, 66.0, and 77.0. All right. Let's first print what we have, but I do want to do a union, an intersection, and a difference. So let's go ahead and take a look at the sets. So we have float set 1, 33, 11, 44, and 22. And 11 is within the float set 1, and 55 is not within float set 2. I mean, on float set 1. 55 is not within float set 1. 11 is not within float set 2, but 55 is within float set 2. As you can see, 55 is here, and that's why this is true. And 11 is here, and that's why this is true. Okay, so let's do the union. Basically, intersection. Oh no, we want to do a union. Union of sets, and there's an operator for union. You basically take float set 1, and you use the OR bitwise operator, and then you use the other float set, or the other set. And basically what we get is a true, wait, no, not true or false. What we get is a union of the set. So it basically merges them together. So let's print that out. Okay, so this one is the float sets union. All right, so union of sets. And let's see what the float sets union comes back with. Okay, yeah, so as I said before, we had 8 values in total, 11, 22, 33, 44, 55, 66, 77, and 44. And what we have here is 1, 2, 3, 4, 5, 6, 7 values. And because the sets can't have duplicates, it removed the 44. So we actually have 7 values instead of 8, because 44 is in both sets. So this is how the union looks. Let's go ahead and do a intersection. Intersection of sets. And the bitwise operator for intersection is the ampersand or the and. And let's see, float sets intersection, right? And this should show the intersection between the two of these. So with sets, you have all of the values here that exist and then all of the values here that exist. So if it was a Venn diagram and they overlaid where things were the same, that would be the intersection. So wherever things are the same is where the intersection happens. And 44 is the only thing that's the same between these two. And that's why it's going to print just the 44. Yeah. So that's the intersection. And lastly, we need to do the difference. Yeah. Okay, and as you might imagine, the difference between two sets would be with a subtraction sign or a subtraction operator. All right. So what happens here is the first set has all of its components, but whatever is inside of the second set that matches the first set is going to take it away from the first set. So basically what we're going to end up with is 11, 22, and 33, and 44 is going to be missing because 44 is inside of float set 2. So let's go ahead and show the difference here. Yeah, so 44 is gone. So the float set's difference has 33, 11, and 22. And the 44 is missing because the second set had a 44. And the difference would be whatever is in the second set that is also in the first set, take it away from the first set. So let's do another difference, but in the opposite direction. So this will be float set 2, and then this will be float set 1, and this will be difference 2. All right, and let's see what that comes up with. So, oh, I subtracted it from itself. All right. So, yeah. So what we get is the second set with 66, 44, 77, and 55. And because the first set has 44 and the second set has 44, it removes the 44 from the second set. And then this is what we're left over with from the second set, 66, 77, and 55. All right. That looks like that is all of the questions. So we can close off with what the next lesson is supposed to be on, Python methods. We did some of the Python methods with the objects, Python objects lesson. And then we've been using functions in Python as well with the main. And every one of these function calls that we do with print and the append and all of those are methods. But what I want to do is a deeper dive into methods, basically to kind of like explain it and make it as clear as possible, you know, what the purpose of methods are and what their limitations are and all of these things. All right, last thing, if you want to make a lesson suggestion, if you have a question that didn't involve collections, and maybe it's about files, Python files, maybe it's about Python databases, please take a step over to our lesson suggestions and type out exactly what you want in a lesson, and we'll cover it. Have a good night, guys.